this is the empirical instruments arranged by scientists at around 250 years ago. Our chemistry lesson starts from this law of stoichiometry. That means as we do unitary method in arithmetic, the name changes to stoichiometry in chemistry, the laws of stoichiometry. The laws that govern, regulates, indicates how chemical reaction takes place and how we relate between the quantities, as for example mass and volume, how we relate mass and volume in a reaction. We have to keep in mind that in this era, in this 1750 like or 1770 like times, people were unaware of atoms. They did not discover atom that very stage. The law of stoichiometry, the first law is conservation of mass. The law of conservation of mass, the law was explained by Lavoisier at 1774. The law states that in a chemical change, the total mass of the reacting substance is equal within the limits of experimental error to the total mass of the products of the reaction. Reaction, however, before the reaction and after the reactions, mass are equal. Let me introduce some historical events or incidents around 1770 and 1780. What were happening in the world around this time? When Lavoisier stated the law of conservation of mass, in the same time, around 2, 3, 4 years ago or before, Beethoven was born at 1770. Beethoven, the musician. James Cook was on voyage at 1772. Slavery outlawed in England. There was a ritual to buying and selling mankind. You could have bought a able-bodied man from market in the era of 1200, 1300 and before that. Mankind was treated as commodities and can be traded in market. Slavery outlawed in England in 1772. That means England market prohibited sale and buying of humankind. Daniel Rutherford discovered nitrogen. Atomic structure, Rutherford is not. This is Daniel Rutherford who discovered nitrogen. That means he imagined nitrogen, an element as nitrogen. In 1772, potato was declared edible in France. Potato. Man can consume potato, it is not poisonous. At that time, American patriots dumped tea packets or tea trunks of East India Company in Boston Harbor. They were outraged, angry for the East India Company, against the East India Company, and they dumped tea packets. Lots of tea packets were dumped in Boston Harbor. Benjamin Franklin, the kite scientist, was dismissed by Postal Department from Deputy Postmaster for neglect of postal duties in 1774. In 1774, Lavoisier, the law of conservation of mass was stated or formulated. At that time, few incidents happened all over the world like these. Benjamin Franklin, famous scientist, was dismissed from his postal job in 1774. In India, 1774, Great Famine of Bengal. Warren Hastings took charge 1772, and 1772 Ram Mohan took birth in India. Ram Mohan Roy. All over world there was not peace at all. Still science was there, and Lavoisier and his colleagues doing scientific experiments with few crude instruments. Then comes the law of constant proportion. Two compounds with same element, A plus B, reacting to form X and Y. Let there be numbers A, X, etc. This is the reactants. They are reactants, and these are products. Sum of their mass will be equal to the sum of the mass of the products. This is law of conservation of mass. Here experimental error is neglected. That means you cannot measure mass exactly. Always there is scope to measure more accurately. So to some extent there will be error. If we neglect this error, sum of this mass and sum of this mass will be equal. This is the law of conservation of mass. Number 2, law of definite proportion. Definite proportion. What is it? You take CO2 and CO as for example. CO2 and CO as for example. CO2 means 12 gram C and 32 gram oxygen, and CO 12 gram C, 16 gram oxygen. This fixed amount carbon is reacting with 32 and 16 gram of oxygen. 12 gram fixed carbon is reacting with 32 gram of oxygen and 62 gram of oxygen, and their ratio is 2:1. That means this is simple ratio. This is the law of definite proportion. Not rocket science at all. A simple law. This simplicity after 100 years brings the complex atomic structure, but that was, and this was the basic laws. 1803, Dalton postulated his famous atomic theory. Before that, scientists even don't know O is 16, carbon is 12 or 6, hydrogen was 1. 200 years, nearly 150 to 200 years time taken to discover the simple things which we know, class 7 boys and girls know, but famous scientist Lavoisier was unaware of that facts. He was unfortunate. Definite proportion was postulated or discovered by Proust in 1797. Definite proportion, Proust, 1797. Another example of definite proportion is phosphorus pentoxide and trioxide, P2O5. 2 into 32 gram of phosphorus reacting to 3 into 16 gram of oxygen, and 31 will by unitary method 16 by 2, that means 24 gram. In P2O5, 2 into 31, 5 into 16, 31, 5 into 16 by 2, that means 40. Ratio of these 24 and 40 is 24 is to 40, cancellation by 8, 3 is to 5. This is the simple ratio, and phosphorus oxides follow definite proportion law by formulated or discovered by Proust in 1797. And it is interesting to show that valency of phosphorus is 3 is to 5, and these different oxygen are in 3 is to 5 ratio. This leads to discovery of some fundamental particles and fundamental laws. Another stoichiometric law is law of multiple proportion. Law of multiple proportions, discovered by Dalton in 1803. Before Dalton's hypothesis or Dalton's atomic theory, he proposed law of multiple proportion. What is it? 3 compounds, CH4, H2O and CO2. If carbon is taken, 12 gram of carbon adds to 4 gram of hydrogen and 32 gram of oxygen. 12 gram carbon adds to 4 gram oxygen, 4 gram hydrogen and 32 gram oxygen. Ratio is 4 is to 32. That means 1 is to 8. And these 1 is to 8, when hydrogen and oxygen reacts each other, they follow this rule, this ratio. When hydrogen and oxygen reacts with each other to form water, they maintain the ratio. This is the same. This is same. Somewhere intrinsic similarity is there, some relationship is there. Why 12 gram of carbon adding to 4 and 32 gram of oxygen, and their ratio is maintained when hydrogen and oxygen reacting to each other. Some relationship is there yet to discover, and that we have to wait to happen. I jumbled up the names. Some mistakes are there. This definite proportion will be multiple proportion, and this is Dalton. Multiple proportion is Dalton. Carbon dioxide and phosphorus pentoxide all are examples of multiple proportions. And this example which I told previously, multiple proportion, this is reciprocal proportion, and this Dalton, it is not Dalton, it is Richter. Richter in 1792. Richter, this law is multiple proportion or law of equivalence. This methane, water, carbon dioxide is the example of law of reciprocal proportion. Carbon dioxide and phosphorus pentoxide are examples of multiple proportion, and I jumped or galloped law of definite proportion. So there is some mistakes. One law is ignored, that is Proust in 1977. Proust 1797. Proust, CO2 you collect from any source, it will have same ratio of mass between carbon and oxygen. This is the law of constant proportion. Sir, if it is CO2, then always it will be 12:32. Therefore, everybody knows it. What is the law? What is the newness in it? We are writing now 12 and 32. That numbers were unknown to them in 1797. People were not unaware of these numbers. So they find X gram of carbon and Y gram of oxygen forming CO2. Even this is the ratio X is to Y. And another scientist did same experiment, and that was A is to B. And this will be equal. X is to Y is A is to B. And this is not 12:32. 12:32 is easier, and same for every CO2. This law is stated by Proust in 1797, and same two elements forming two different compounds, SO2 and SO3. 1 gram S in each case, adding to oxygen 16/32 is to 32/32 is to 48/32. This will be 1:2:3 ratio. This is the simple ratio, and this is the law of multiple proportion. And law of reciprocal proportion, you take SO2, H2S and H2O. Sulfur as fixed element, 32 gram of sulfur adding to 32 gram of oxygen and 2 gram of hydrogen. Ratio 32:2, 16:1. And when oxygen and hydrogen reacting to each other, H2O is formed, and the ratio is 16:2. That means 8:1. Compare this ratio with 16:1. This is the multiple of this. 16 means 8 into 2 is to 1. This 8 is there. This is simple number 2 is multiplied and this number is related to as submultiple or multiple. This law is reciprocal proportion discovered by Richter in 1792. Another law left, this is Graham's law. H2 plus Cl2, we get 2HCl. Volume ratio at same temperature and pressure, is 1:1:2, 1:1:2. When the reagent and products are gas, they maintained a simple ratio of their volumes. Their volumes will be in a simple ratio. This is Graham's law. 2NH3 breaks N2 plus 3H2. 2 liter ammonia breaks to 1 liter nitrogen and 3 liter hydrogen. That means 2 liter will be 4 liter. Volume increases here. 2 liter ammonia when breaks, you get 1 liter nitrogen and 3 liter hydrogen at same temperature and pressure, and 2 liter will be converted to 4 liter. When we break ammonia, there is a volume increase.